to understand the main point, suppose I say e power ax dx, then everybody will say the answer is e power ax upon a. But it is not fully correct. What is the mistake in it? You will understand when I will do the solution. Similarly, just for knowledge, I am telling you, for example, if I say, everybody will say the answer is sin inverse x by a. But again, it is not fully correct. And what is the mistake in it? That I will tell you at the end of this video. And the mistake in this you will understand while seeing the solution of this question. In this question, it is given that for any real number alpha and beta, let y alpha beta x be the solution of the differential equation this. Let s is equal to y alpha beta x, where alpha and beta are real number. Then which of the following functions belong to this set S? That is, the set S is the set of all possible solution of this equation, and you have to check which of these functions are solution of this differential equation. And to proceed, it is clear that it is a linear differential equation. And in the questions of linear differential equation, first of all, we always find integrating factor. The integrating factor in this case will be e power alpha dx, that is e power alpha x. And after finding the integrative factor, we know that the solution is y into e power alpha x, that is integrative factor, is equal to right hand side, which is here x e power beta x into, you must be knowing this is the solution of the linear differential equation. And after this, y into e power alpha x is equal to x e power alpha plus beta into x dx plus c. And this means y into e to power alpha x is equal to x e to power alpha plus beta into x, I'm integrating by parts, minus e to power alpha plus beta into x upon this is a step to which most of the students will proceed after this step. But actually, this is not fully correct. After this step, the question divides into two parts. Actually, this is the step allowed only if alpha plus beta is non-zero. If alpha plus beta is 0, then the question move in a different direction. If alpha plus beta is 0, in that case, we say y into e to power alpha x equal to x square by 2 plus c. It is clear from here. Hence, we have got two possible solutions. One, and for second possible solution, you will have to integrate it. To bring this solution in choices form, I divide both sides by e to power alpha x, and we get y equal to x e to power beta x upon alpha plus beta minus e to power beta x upon alpha plus beta whole square plus c e power minus alpha x. Hence, we have got two possible solutions. This when alpha plus beta is 0 and this when alpha plus beta is non-zero. And now, choices A and B can be derived from here only, cannot be derived from here because in choices A and B x square is there and in this solution x square is not there. Hence, let us check whether for some value of alpha this can be this or not. Now we will see whether this can be this or this for some value of alpha or not. And again, to bring this in choices form, first I divide by e to power alpha x. I will get y is equal to x square by 2 plus c into e to power minus alpha x. And now see, this can reduce to this if alpha is 1. If alpha is 1, then you will get y is equal to x square by 2 into e to power minus x plus c e to power minus x. And now we will find the value of c, and if the value of c comes to be this, then I will say this is correct answer. And to find the value of c, it is given that for x equal to 1, the value of y is 1. Hence, using it, I get 1 is equal to e to power minus 1 by 2 plus c e to power minus 1. That is c is equal to e minus 1 by 2. And because the value of c is this, and putting back the value of c here, I can say A is the correct choice. Clearly B cannot be correct because for any value of alpha, this cannot be this. Hence B is sure to be a wrong choice. And now to check C and D, and let us see, can this convert to this for some value of alpha and beta? It is clear that this can be if I take the value of alpha plus beta is equal to 2, because for alpha plus beta equal to 2, then we will get x by 2 here, x by 2. And it is also clear that for bringing e to power x, I will have to take beta equal to 1. And once beta is 1, it means alpha will also have to be 1. And let us check for alpha and beta equal to 1, can this be same as this? Now see, for alpha and beta both equal to 1, it is clear that I'll get y equal to x e to power x by 2 minus e to power x by 4 plus c e to power minus x. Now this can be same as this once the value of c matches with this. And c is very easy to find because it is given that for x equal to 1, the value of y is 1. Hence I get 1 is equal to e by 2 minus e by 4 plus c e to power minus 1. And this means c is equal to e into 1 minus e by 4. That is c is equal to e minus e square by 4. And it is clear that for this value of c, this will match with this. Hence c is also correct. And now let us check about choice D. In choice D, minus x by 2 e to power x is present, and this can reduce to this if I take the value of alpha plus beta equal to minus 2, because it is minus x e to power x by 2. And comparing this and this, I will have to take beta equal to 1. Then only this can convert to this, and beta equal to 1 means alpha will have to be taken as minus 3. Now we will have to check for this value of alpha and beta, can this be converted to this or not. And if we put this value of alpha and beta here, see what happens. I get y is equal to x e to power x by minus 2 minus e to power x by minus 2 square plus c e to power 3x. And it is clear from here, this and this can never be same. Whatever the value of c we get after taking this initial condition, because c is simply a constant. Therefore, this can never match with this. Hence, D is wrong choice. And as I have told you in the beginning that I will tell you the mistake in this formula also. The mistake lies here that this formula is correct only if A is positive. For negative values of A, the integral is minus sine inverse x by A. This is the integral when A is negative. This is the integral when A is positive. For board level, these things don't create any problem, but for JEE Advanced at least, the examiner can easily make the question in which those students who use this formula get wrong answer.